Yes, students, good morning, everyone.
Good morning, ma'am.
Yeah,
Good morning, ma'am.
morning, good morning. Yes, okay. So, sir has introduced me already anyway. So, I'm Shruti, completed MPhil in chemistry. So, now working as a CBSE school teacher for 11th and 12th standard. Okay, see, very simple. Wherever you have a doubts, feel free to ask. Okay, no need to get hesitate. Feel free to ask your doubts. Clear,
Yes.
everyone?
Okay, ma'am.
Yeah, fine. Yes. Okay, so today let's start with the first lesson. What is the first lesson in chemistry? Any one of you?
Madam, one more thing I forgot to tell you. Most
Yes,
of the
sir.
students are from state board students, but
Okay, sir. Fine.
I request you to
Go.
follow the CBSE books because we want to give a
Yeah, sir.
blend. But lesson wise, you may be able to you start from the state board first lesson or something. But
Okay,
use
sir.
the CBSE book so that our students will get to know the details, our in-depth knowledge on that particular subject.
Yeah, sir.
Yeah,
Right.
thank you,
Okay.
madam.
Thank you, sir.
Some basic concepts of chemistry.
Very good. Some basic concept of chemistry. So, like எல்லாமே நம்ம சிபிஎஸ்சி பேஸ்ட்லேயே போய்க்கலாம். ஸோ சிபிஎஸ்சி பேஸ்ட்னா உங்களுக்கு காம்படிட்டிவ் எக்ஸாமுக்கு ரொம்ப யூஸ்ஃபுல்லாக இருக்கும். தட்ஸ் அ ரீசன் வி ஆர் மூவிங் வித் த சிபிஎஸ்சி புக். Okay, so let's start. The first lesson is some basic concept of chemistry. Like even if you have any doubts in the state board book also, like mostly the topics are very similar. So doubts வர்றதுக்கு உங்களுக்கு chance இல்லை. Anyway, we will discuss. Ready, everyone?
Yes, ma'am.
Okay,
Yes,
so
ma'am.
take your notes எடுத்துக்கோங்க. எங்கெங்க basic points இருக்கோ I want you to yes take it on the basic points. So நான் எல்லா பாயிண்ட்ஸுமே சொல்றேன் எங்க உங்களுக்கு இம்பார்ட்டன்ட்னு சொல்லிட்டேன். So some basic concept of chemistry. Okay, let's go with first chemistry. What is in chemistry? Any one of you? Chemistry na என்னது first of all? Yes. கண்டிப்பா உங்களுக்கு தெரியும். What is your idea in chemistry? Yes.
Ma'am, just like how physics is study of physical state of objects, I think chemistry is the study of chemical states of objects.
Very good, super. Chemistry is a study of chemical objects. So, like, what is in chemical objects we used to say? Like chemicals, which is simply let's mix hydrochloric acid with the sodium hydroxide, right? That is a kind of a chemical reaction. So, we can simply say study of chemical reactions is known as in chemistry, right? Am I correct?
Yes, ma'am.
Okay, so simply study of chemical reaction is known as chemistry. Okay, what is the branches of chemistry? Any one of you know? So it should be an interactive class. I'm expecting everyone to say the answer. Okay, evlo branches of
organic,
chemistry?
inorganic.
Super, very good. Organic, inorganic. Any other branches?
Physical.
Very good. Physical, super. So three branches are physical, organic, inorganic. These three are very, very important branches. இது இல்லாம நம்மளுக்கு பயோ இன்ஆர்கானிக் அனாலிட்டிக்கல் கெமிஸ்ட்ரி அதெல்லாம் இருக்கு. பட் இன் டேர்ம்ஸ் ஆஃப் ஹையர் செகண்டரி நம்மளுக்கு இந்த த்ரீ பிரான்ச்சஸ் தான் ரொம்ப இம்பார்ட்டன்ட். நவ் லெட்ஸ் கம் டு வாட் இஸ் பிசிக்கல் கெமிஸ்ட்ரி. பிசிக்கல் கெமிஸ்ட்ரி நம்ம என்ன படிப்போம்? ஏதாவது ஐடியா இருக்கா பிசிக்கல் கெமிஸ்ட்ரியில? The first chapter in the CBSE book is actually from the physical chemistry. Physical chemistry naale calculations. So mostly kind related to the physics. So calculation இருக்கும். ஒரு ரியாக்ஷனை வந்து எப்படி ஸ்பீட் அப் பண்ணலாம், ஏன் ரியாக்ஷன் ஸ்லோவாக இருக்கு, ஸோ எதனால ஈல்டு கம்மியாக இருக்கு, அது மாதிரி டெம்பரேச்சர் இன்க்ரீஸ் பண்ணால் ரியாக்ஷன் நல்லா இருக்குமா, இல்லை ப்ரெஷர் இன்க்ரீஸ் பண்ணால் ரியாக்ஷன் நல்லா இருக்குமா, இதை பற்றி ஸ்டடி பண்ணுறது தான் ஃபிசிக்கல் கெமிஸ்ட்ரி. கிளியர் எவ்ரி ஒன்?
Okay, ma'am.
Yes, ma'am.
Very good, super. Let's come to the inorganic chemistry. Okay, inorganic chemistry pati any ideas? Okay,
Doing
Yes.
chemical reactions.
doing chemical reactions, super.
Chemistry is about something that is not organic. Organic is carbon, hydrogen, oxygen. I think anything other than that is inorganic.
Very good, fantastic. Yes, organic chemistry is study of carbon and hydrogen. So other than carbon and hydrogen will come under in inorganic chemistry. So inorganic chemistry, if you heard the word, definitely periodic table should come to in our mind. Okay, everyone know about periodic table, right? What is it periodic table?
Periodic table is a table in which elements are classified based on certain qualities.
Very good, superb. So in which all the elements are arranged based on the atomic number. Atomic number wiseல நம்ம எல்லா எலிமெண்ட்ஸையும் அரேஞ்ச் பண்ணி வச்சிருக்கோம் பீரியாடிக் டேபிள்ல. ஸோ நீங்க எல்லா எலிமெண்ட்ஸ் பத்தியுமே படிக்கிறது வந்து இன்ஆர்கானிக் கெமிஸ்ட்ரி, ஒரு ஜென்ரல் கிளாசிஃபிகேஷன் மாதிரி இன்ஆர்கானிக் கெமிஸ்ட்ரியில படிப்பீங்க. ஆர்கானிக் கெமிஸ்ட்ரியில பாத்தீங்கன்னா ஒன்லி கார்பன் அண்ட் தென் ஹைட்ரஜன். ஓகே, டோட்டலா பீரியாடிக் டேபிள்ல 118 எலிமெண்ட்ஸ் இருக்கு. அதுல ஏன் நான் கார்பன் ஹைட்ரஜன் மட்டும் பத்தி படிக்கணும் ஸ்பெசிஃபிக்கா? எனி ரீசன்? Why we want to learn about only carbon and hydrogen? Any reason? Because ella like world la irukra most of the substances are made up of carbon. Okay, that's the main reason. Adanal da nama carbon patti specifically padikrom. Most of the things are made up of carbon. That is the main reason. Clear? Why the organic chemistry has formed?
Yes, ma'am.
Yes, ma'am.
See, first is about just simple introduction. So introduction, I think you people can go through it. கண்டிப்பா ஒன்ஸ் கிளாஸ் முடிஞ்சதுக்கு அப்புறம் என்னென்ன நோட்ஸ் நம்ம பார்த்துருக்கோம்னு பாருங்க அண்ட் புக்கை ரீட் அவுட் பண்ணுங்க. தட் இஸ் வெரி இம்பார்ட்டன்ட். ஓகே, எஸ், நவ் லெட்ஸ் கோ வித் மேட்டர். ஓகே, யா, மேட்டர். திஸ் டெஃபினேஷன்ஸ் we have learned in your lower classes. மேட்டர்னால என்ன டெஃபினேஷன் கொடுக்கும் யூஸ்வலா?
Anything which occupies space.
வெரி குட், சூப்பர். எந்த ஒரு சப்ஸ்டன்ஸாவும் இருக்கலாம், அதுக்கு மாஸ் இருக்கணும் and it occupies some space or it has some volume. This is a matter, right? Okay, now tell me, what matter is made up of what? Matter எதனால ஃபார்ம் ஆயிருக்கு?
Atoms.
Very good, very good. Matter is made up of an atom. So atom is a building block of all the substances, right? Atom is a building block of all the substances. Yes, fine. Let's come to states of matter. What is the states of matter?
Solid, liquid, gas.
Very good. Solid, liquid, and gases. Properties. Any one of you will say about solid? Solid.
The atoms in solids are arranged closely, ma'am.
Super.
And the atoms in liquids are arranged loosely than those in solids, and the atoms in gases are arranged loosely than they are in liquids.
Very good. Fine. Yes. So the arrangement, about the arrangement, solids, the atoms are closely packed. In liquids, it's moderately packed, and gases ரொம்ப லூஸா packed ஆயிருக்கும். So this is about the solid, liquid, and gases. Okay. Then let's discuss about the force of attraction. So force of attraction discuss பண்ணா எப்படி பேசலாம்? Force of attraction.
The force of attraction between the atoms in solids are stronger than those in liquids, and gases have the weakest force of attraction between them.
Very good. So in the case of a solid, all the atoms are tightly packed, right? நம்மளுக்கு எல்லாம் க்ளோஸா பேக் ஆயிருக்கு. அப்படி க்ளோஸா பேக் ஆயிருந்ததுன்னா force of attraction எப்படி இருக்கும்? ஸ்ட்ராங்கா இருக்கும். So இங்க again the force of attraction is moderate, and the gas it is very loosely packed, so that the force of attraction is very very less than the solid and liquid. இது எல்லாமே நம்மளுக்கு basic points தான். I think you have learned already in your lower classes, right? Definite shape, definite volume, இதெல்லாமே நம்ம already பார்த்திருக்கோம். So let's go into the concept like in detail. Okay, so matter, classification of matter. Matter are classified into two things mainly. One is mixture and another one is pure substances. So let's differentiate the mixture and pure substances first. Mixture அப்படின்னா என்னன்னா, ஃபார் எக்ஸாம்பிள் நம்ம வந்து சாப்பிட்றதுக்கு மிக்சர் எடுத்துக்கோம், ரைட்? அதை கூட ஒரு பெஸ்ட் எக்ஸாம்பிளா எடுத்துக்கலாம் மிக்சருக்கு. ஏன்னா அதுல எப்பயுமே ஒரு ஃபிக்ஸ்டு ப்ரொபோர்ஷன் இருக்காது. ஓகே, ஸோ லைக் ஃபிக்ஸ்டு ப்ரொபோர்ஷன் இன் த சென்ஸ், நீங்க ஒரு கடையில வாங்குறீங்க, அதுல வந்து நட்ஸ் வந்து ஒரு 50 கிராம் ஆட் பண்றாங்க. இன்னொரு ஷாப்ல வாங்குறீங்க, அதுல 100 கிராம் ஆட் பண்றாங்க. லைக் இட் இஸ் நாட் இன் ஃபிக்ஸ்டு ப்ரொபோர்ஷன், ரைட்? எல்லா இடத்துலயும் ஒரே மாதிரி தான் வந்து நட்ஸ் இல்ல வந்து லைக் கறி லீவ்ஸ் எல்லாம் ஆட் பண்ணுவாங்களா? Is it like that? No, right? So mixture-நாலே இம்பார்ட்டண்டா உங்களுக்கு என்ன வேர்டு தான் ஞாபகம் வரணும்? Not fixed proportion. அங்க எதுவுமே வந்து fixed proportion-ஆ இருக்காது. பட் பியூர் சப்ஸ்டன்ஸ்னா என்ன சொல்லலாம் நம்ம? It is an fixed proportion. அங்க இருக்கிறது எல்லாமே வந்து either fixed ratio-ல இருக்கும், அப்படி இல்லைன்னா வந்து fixed proportion-ல இருக்கும். This is the important word in the mixture and then pure substances. Yeah. Now again the mixtures are classified into two types. One is homogeneous and another one is heterogeneous mixture. இந்த வேர்டும் ஆல்ரெடி நம்ம லோவர் கிளாஸ்ல கேள்விப்பட்டிருப்போம் நினைக்கிறேன். எஸ், anybody, what is an homogeneous mixture?
Homogeneous mixture, the mixture which mix, it will not அது தனியா தெரியாது மிஸ். It will not show the
வெரி குட். தனியா எதுவுமே தெரியாது. ரெண்டுத்தையும் நீங்க மிக்ஸ் பண்றீங்கன்னா நீங்க அதுக்கப்புறம் தனியா உங்களால பார்க்க முடியாது. த பெஸ்ட் எக்ஸாம்பிள் இஸ் சுகர் சொல்யூஷன். சுகர் எடுத்து நீங்க வாட்டர்ல போட்டுருங்க. ஸோ சுகர் ஒன்ஸ் டிசால்வ் ஆயிடுச்சுன்னா இஸ் இட் பாசிபிள் டு see the sugar separately and water separately? No, right? கண்டிப்பா நம்மளால பார்க்க முடியாது. அப்ப என்ன வேர்ட் எக்ஸாக்டா கொடுக்கணும்னா யூனிஃபார்ம் கம்போசிஷன். ஃபார் எக்ஸாம்பிள் இங்க சுகர் சொல்யூஷன் நம்மளுக்கு ப்ரிப்பேர் ஆயிடுச்சு. இந்த சுகர் சொல்யூஷன்ல நீங்க இங்க இருந்து சொல்யூஷன் எடுத்தாலும் which is a sugar solution, இங்க இருந்து நீங்க sugar solution எடுத்தாலும் this is a sugar solution. So இது வந்து எந்த டிஃபரன்ஸும் இருக்காது. லைக் டாப் லேயரும் sugar solution தான், பாட்டம் லேயரும் sugar solution தான். This is what homogeneous. So சிம்பிளா என்ன சொல்லலாம், which is uniform composition. Let's come to heterogeneous. Yeah, so just opposite. So non uniform சொல்லலாம். என்ன எக்ஸாம்பிள் கொடுக்கலாம்? I want everyone to say
soil with water.
Very
and
good.
oil with water.
Very good. Soil with water, oil with water. So soil with water எடுத்துட்டேன்னா எனக்கு water இருக்கும், all the sand particles settle down ஆயிடும். It is not a uniform composition. So நான் மேல இருந்து எடுக்கனா water மட்டும் தான் வரும், கீழ இருந்து எடுக்கும்போது sand plus water வரும். So it is not a uniform composition. So non-uniform composition is heterogeneous and homogeneous is uniform composition. See எல்லாமே note down பண்ணிக்கோங்க. Just like hints மாதிரி தான் நான் பாயிண்ட்ஸ் கொடுக்குறேன். Okay, you can write it like this same way. இது மாதிரியே நம்ம எழுதிக்கலாம். Okay, now let's come to, is there any doubt so far? இது வரைக்கும் கிளியரா எல்லாத்துக்குமே?
Yes, ma'am.
Yes, ma'am.
Super. Yes, let's come to the pure substances. Pure substanceல பார்த்துட்டோம் அப்படின்னா நம்மளுக்கு ஃபிக்ஸ்டு ப்ரொபோர்ஷன் இருக்கும் தெரியும். பியூர் சப்ஸ்டன்ஸுக்கு போறதுக்கு முன்னாடி we will discuss about atoms. Atom அப்படின்னா என்ன ஃபர்ஸ்ட்? What is mean by atom?
Madam, ஒரே ஒரு சின்ன ஒரு suggestion,
Yes, sir.
madam.
Yes, sir.
You can use English as much as possible.
Okay, sir.
கொஞ்சம்
Fine,
தமிழ்
sir.
யூஸ் பண்ணிக்கலாம். என்ன ரீசன்னா, there are
Yes,
some
sir.
North Indian students are watching our YouTube video.
Oh, fine,
அவங்களோட
sir.
கம்ப்ளைண்ட் என்ன, நீங்க எல்லாம் தமிழ்ல பேசிடுறீங்க. இன்ஃபேக்ட் ஒன் ஃபெலோ ஃப்ரம் முசஃபர் நகர், நோ இன்ஃபேக்ட் இஸ் சென்ட் அ மெசேஜ் ஆல்சோ. ஒரு பையன் பூனாவில இருந்து,
sir.
ஒரு அதிகமா இல்லை, ஒரு 10-20 ஒரு 100 பேர் கூட இருக்க மாட்டாங்கன்னு நினைக்கிறேன். Out of our
Okay,
4,800, still we thought we will try to the extent possible to use
Yeah, sir,
English.
fine, sir.
Okay. குழந்தைகளா, உங்களுக்கு ஒன்றும் ப்ராப்ளம் இல்லையே?
No, sir.
நீங்க தமிழ் பேசிக்கிங்க, நோ ப்ராப்ளம். பட் ஆசிரியர் பேசுறது வேணா இங்கிலீஷ் இருந்தா, சில ஒரு ஸ்பெசிஃபிக் கம்ப்ளைண்ட் வந்ததுனால தான் நான் அப்புறம் ரிக்வெஸ்ட் பண்ணிக்கிறேன். சரிங்களா?
Yes, sir, fine, sir.
Thank you.
Okay, so let's discuss about atom. So what is an atom?
An atom is the smallest particle of matter that takes part in any chemical reaction, ma'am.
Very good, superb. Atom is the smallest particle which is takes part in the chemical reaction. What is the shape of an atom? Yes. What is the shape of an atom? It is sphere. Shape of an atom is sphere. So it's not a circle, it's a sphere. So in 3-dimensional, it is sphere. So let's take about the atom. Like you have, let's consider hydrogen atom. So atom in the sense it is only in one sphere. Am I correct? Atom means it is only in one sphere. So you are mixing an hydrogen atom with the other hydrogen atom. So same types of atom joined together means which is called as element. Are you clear? Same type of atoms together means which is actually an element. This is what the important word, same type of atom. Okay, yes. If this is a compound means different types of an atom but in a fixed proportion. Different types of atom in fixed proportion. This is what the important word for the compound. So let's go with some example. Will you give me some other example for elements? So elements means we know that it is made up of the same type of an atom. Any other examples other than hydrogen, H2?
Oxygen, nitrogen.
Very good, superb. Nitrogen, N2, and then oxygen, O2. These are all made up of same type of an atom, right? So same type of an atom means definitely it is an element. Let's take 24 karat gold. Is it an element or a compound?
It's an element, ma'am.
Very good, superb. It's an element, 24 karat gold. Because in that case, everything, all the atoms are AU, 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 right? So gold, AU is a symbol of gold. So everything is actually gold atom. So wherever the atoms are similar, we can say that as element. Compound means it's a different type of an atom. Any example for the compound?
Carbon dioxide, glucose,
Superb.
and
Carbon dioxide,
hydrogen.
water,
Glucose.
NH3,
Hydrogen chloride.
ammonia, hydrogen chloride. Yes, very important thing. The atoms, the different types of atoms involved in the compound should be in the fixed proportion. For example, let's take a carbon dioxide. It should be in one carbon with the two oxygen. I couldn't say that it's a CO3 or it is in CO4. Correct. The atoms involved in the compound must be in the fixed proportion. The carbon dioxide means it is CO2. Water means it is H2O. I think hope everyone's clear about element and compound, right?
Yes, ma'am.
Fine. Yes. So
Ma'am, I have a little doubt.
yeah, yes.
So ozone and sulfur, the eight, so S8, are they
It's
elements?
also element. S8 is also an element.
Yes, ma'am.
Yeah. Yes. So this is what the definition given in the book. Kindly go through it. Yeah. Let's come to the compound. We have finished. Physical properties. These are all the basic things only, students. It's about only the SI units. So SI units, you know already about mass. Mass SI unit is kilogram.
Kilogram.
Length is, yeah, fine. Length SI unit is meter. Time is second. This is also just basic things. So we will go with the depth concepts. Yeah. Okay. This is also you learned in the lower classes. What's the difference between the mass and weight?
Mass is the amount of matter in a body, and weight is how much gravity is acting on a body, ma'am.
Perfect. Yes. So mass is actually the actual amount of matter present in a particular substances. But weight, the weight will vary from place to place, like planet to planet. So in Earth, if you have noted down the weight, it is different. But in the case of other substances, like in other planet, the weight will differ. But the mass will same in all the planets. Okay. So weight is based on the gravity, but mass is actual amount of matter present in it. That is the difference. And we know that SI unit of mass or weight, it's a kilogram, and 1 kilogram is equal to 1000 gram. These things are very important. So 1 kg is equal to 1000 gram because this will be used while we are doing some problems. Okay, note it down. 1 kg is equal to 1000 gram. Let's come to volume. What is in volume? Yeah.
Volume is the space that an object occupies.
Very good. So a substance or an object, how much space it occupies is known as a volume. And the SI unit of a volume is meter cube. All those things are very important. It will be helpful for the problems. Okay. And the conversion is also very important. See, 1 liter is equal to 1000 ml and 1000 decimeter cube is equal to 1 decimeter cube. All those things are very important. And even here, volume is 1000 centimeter cube. So actually 1 centimeter cube is equal to 1 ml. Okay, this is 1 ml. And then 1 decimeter cube is equal to 1 liter. All those things are very important. I want you people to take down as a hints all those things. Finish, right? Okay. In case if I'm moving fast, tell me. We will do slow.
Ma'am, can you please show me that picture again, ma'am?
Yeah, fine.
Thank you, ma'am.
Yes. Finished, ma?
Yes, ma'am.
Good. Okay. Let's come to the density. Density has a formula of mass by volume. What is the mass of the density? Like what is the unit of the density? Unit of the density is kg and the volume SI unit is meter cube. So the meter cube will come up so that it becomes m to the power of -3. So this is a formula for density. The unit of density, mass by volume is a formula. This is also one of the important one we will be using regularly. Density is equal to mass by volume. So and the unit of density is kg meter to the power of -3. This is also very important. Note it down. Okay, let's move to the temperature. What is the temperature?
The amount of heat energy in a body.
Very good. The amount of heat energy in the body. Fine. Yes. So what are all the units of temperature?
Kelvin, Fahrenheit,
Kelvin,
Celsius.
Fahrenheit,
Yes,
degree
Fahrenheit.
Celsius. Yeah, fine. Okay, super. So which is an SI unit of temperature?
Kelvin, ma'am.
Kelvin.
Yeah, fine. Yes, Kelvin is an SI unit of. That would be enough for the temperature. It is an SI unit of temperature. Let's come to the scientific notation. This will be very helpful. Okay, so scientific notation. So, will you people tell me what is 10 square?
100, ma'am.
100.
100. What is 10 cube?
1000.
1000. Very good. 1000. I think everyone heard about Avogadro number, right?
Yes, ma'am.
Yes, ma'am.
Yeah. What is an Avogadro number?
Equal volume of organic.
Yes, super. 6.022 into 10 to the power of 23. Is it a big number or a small number?
Big
It's
number.
a big number.
It's a very big number, right? It is actually an hextrillion. Okay, it's a big number. See, 10 to the power of 2 itself 100 means, then imagine 10 to the power of 23. It's how much big number, right? It is an hextrillion number. So while we are writing, every time we can't put this much zero, right? Then the time got so fly up very easily. So what we need to do, we are moving with the scientific notation. Scientific notation in the sense writing in this pattern. Okay, this is what scientific notation. So we have a common general pattern which is n into 10 to the power of n. This is our common pattern. Okay, n into 10 to the power of n. So like the big numbers, even the very small numbers, we can write it like this. Okay, so let me give you some example. Like first we will go with the general format, n into 10 to the power of n. What does this capital N denotes means? It should be in the range of 1.0 to 9.9. Okay, always the capital N in the range of 1.0 to 9.9. And then what about the small n means? Either it is a positive value or it is a negative value. Okay, are you people clear? Is there any doubt in this general pattern of scientific notation?
No, ma'am.
Fine.
No, ma'am.
Yeah, yes, I will repeat. See, the general pattern of scientific notation should be a capital N into 10 to the power of small n. So what is a capital N here? It should be in the value. It should be in the range of 1.0 to 9.99. So like all the capital N should be in this value only. Okay, and the small n, either it may be a positive value or it may be a negative value. I will go with some problems so that you people will be clear, so much clear. Clear? Is there any doubts?
No, ma'am.
Yeah, fine. So we'll go with the problems. So let's take 232.508. So it is given 232.508. I have to convert this into, okay, we have to convert this into scientific notation. So I have a decimal here, no. So what I need to do, I'm going to put it at 2.3. Okay, because all the capital N should lies between 1.0 to 9.99, right? So it should be 2.32508 into 10 to the power of, listen carefully, I'm moving the decimal into left hand side. Am I correct?
Yes, ma'am.
Okay. So whenever you are moving the decimal into left hand side, definitely it is a positive value. So how many numbers like you are moving to the left hand side? 2 digits. Am I correct?
Yes,
Yeah.
ma'am.
So it is 10 to the power of 2. Okay, very simple. 2.32508 into 10 to the power of 2. So if you look at, this is our capital N and this is our small n. Okay, the small n is now positive value and this is in the range of 1.00 to 9.99. Clear? Right, this is in the range only, no?
Yes,
2.32 falls under and 1.00 to 9.99. Am I right?
Yes, ma'am.
Okay, so I'll give you one more problem. So 4567.23. So who's ready to answer this one?
Can I, ma'am?
Yeah, yes, sure.
So we can write it as 4.56723 into 10 to the power 3.
Very good, perfect. It is 10 to the power of 3. So I'm moving the decimal to 4.5 so that 3 digits are here. So it is 10 to the power of 3. How many of you have doubt in this problem? Are everyone clear?
Yes,
Yes,
ma'am.
ma'am.
Clear, everyone clear, right? In case even if you have a doubts, tell me, we will go once again, no problem. Okay, yes. So let's go with a different kind of problem. One more problem, like 0.001358. So this is our value. So what we need to do? I'm moving the decimal point into the right hand side. So left hand side means it should be a positive value. Right hand side means it's a negative value. So our answer is 1.358 into 10 to the power of, so like the decimal is coming to the right hand side after 1 2 3 4, so it should be 10 to the power of minus 4.
-4.
Perfect. 10 to the power of minus 4. Why it is a negative sign? Because this is a very smaller value. Am I correct?
Yes, ma'am.
This is very smaller value. That's the reason it is negative. If you have taken this one, this is a bigger value, 4 5 6 7. So that's the reason we are putting in positive value. Clear, right? Is there any doubts in this part?
No, ma'am.
Fine. Okay. So here, like, I'm giving only the essence of what is very important and what is must needed. Okay. Yeah. So addition, subtraction, all those things are, it's a very basic things. I think you people can go through it. Let's come to significant figures. Significant figures is also like, mostly we can understand the meaning from their word itself. Significant. What is mean by significant? Something which is important. Fine. Something which is important. Very good. So that is what called as significant figures. Some numbers are important, so they are called as significant figures. Okay. There are some rules to find out the number of significant figures. This is something irrelevant to what we are doing in the day, like regular numbers. Okay. Anyway, these are all the rules we need to follow as it is. Okay. So let's go with how to find the number of significant figures. Okay. Number of significant figures. See, all non-zero digits are significant. Okay. Non-zero in the sense what? Other than zero. Am I right? Other than zero or significant. So how many numbers are here you have?
3, ma'am.
3 numbers, right? So the significant figure is 3. Clear? Is there any doubts?
No, ma'am.
Okay, fine. Let's move to the next point. Yeah, next point is zeros preceding to first non-zero digits are significant. So this is a non-zero numbers. The zeros preceding, so like in front, right? So the non-zero number is 5. So the zeros which is before non-zero numbers, these are non-significant figures. So I have to consider only the 5 too. Remember, if zeros comes first before the non-zero numbers means they are not a significant figures. We have to take only the non-zero digits. So how many non-zero digits are there?
2.
2. So it isn't 2 significant figures. Let's go with one more example. 156. So will you tell me how many significant figures?
3.
Very good. Fine. It isn't 3 significant figures. Yeah, it's right. Let's come to the third one. Third point. Zeros between 2 non-zero digits are significant. Okay. So non-zero digits are also significant. But when between 2 non-zero numbers. Okay. So 2.005 has a 4 significant figures. Are you people clear? Right?
Yes,
This
ma'am.
you can go through it. No need to write it in your note. It will take time. So just go through. Yes. Next one, fourth point, zeros at the end or right of the number are significant. Okay. But here also we have one important point to discuss. See, 0.20. Here actually 3 significant figures. Okay. Because there is a decimal, right? So 0.200 is 3 significant figures. But if you simply take 100, it has only one significant figure because there is no decimal point. Clear, students? If it is a decimal point, then only you have to consider the non-zero numbers. Okay. Sorry, zero numbers. Are you clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes. So, like, now I am putting 100.0. So now if you consider this, will you tell me how many significant figures are there?
2.
It is three significant figures. So wherever you have a decimal point, you can include the zeros. Otherwise, there is a no decimal point for this 100, right? So it is only an one significant figures. Okay, this 100 has only one significant figure. But if you put zero over here, then it is three significant figures. Here the dot is missed. Okay, so if point is there means then it is a three significant figures. So let's see 100.0. How many significant figures? Four significant figures. Are you people clear? 100.0. So we have to take the whole thing. So which is four significant figures. So this will take time to memorize. It is just simply about memorizing. So it's not much about the concept oriented part. Hope you people are clear. Is there any doubts?
No, ma'am.
Yeah. So what we used to say this one, what it is actually? What is this pattern?
Scientific notation, ma'am.
Very good, superb. It is in scientific notation, right? In the case of a scientific notation, you have to check only the capital N for the number of significant figures. So how many numbers, how many significant numbers will come? 1.0 means, of course, it is a 3 because there is a decimal point. So you have to include all the numbers. So it is in 3 significant figures. So that's about the significant figures. Like mostly it is bit confusing part when it comes to the fifth point. See, if I'm writing simply 2 means I can say only one significant figures. Am I right?
Yes, ma'am.
Okay.
Yes, ma'am.
If I'm putting many zeros like this means, of course, 2 point, I can put any zeros. That is, even if I'm putting like 1,000 zeros also, the value will not change. Am I correct? Still, it is 2 only, right?
Yes,
Yeah.
Yes, ma'am.
So this case we can say infinite significant figures. Okay. Like I'm putting one decimal and I'm adding on zeros continuously. So it is an infinite significant figures. Clear, everyone?
yes, ma'am.
Fine.
Yes,
Yes.
ma'am.
Okay. Superb. So let's move to the next part. These things are very basic about dimensional analysis and all. You can just go through what you will do as usually. Like let's take 1 kg. What is 1 kg? 1 kg is equal to how much gram?
1,000 gram.
1000 gram. Okay. So then what is 2.5 kg?
2,500.
2500 gram. Very good. The same thing you can go ahead. So this is dimensional analysis. They have did in a some other method that is not needed. So like when the problem wise, this is what we are following. So as usual method, we can go it. Yeah. Let's come to law of chemical combination. So this is also very simple. The first one is about law of conservation of mass. So law of conservation of mass in the sense, very simple. Did anyone know the definition or law?
From the mass.
Matter can neither be created nor be destroyed. Yes, yes. So simply what we can say, mass of reactant is equal to the mass of a product. Agree, everyone?
Yes.
Right? Yes. So for example, you are preparing a coffee, you are adding in 1 liter of milk to this, adding like like half a liter of water means definitely the together will be your final result of coffee. But if the things are closed, if you do it in the open container, then the water molecule will evaporate, then the mass of a product is different. So if the reactions are taking place in the closed container, definitely the mass of the reactant should be equal to the mass of a product. The matter will not get increased or the matter will not get decreased. That is what they are saying. Matter can neither be created nor be destroyed. Clear, everyone?
Yes, ma'am.
Yeah, fine. Let's come to the definite proportion. Again, from the word itself, we can get the meaning very easily. Definite in the sense something which is a constant. Proportion means it is in the ratio. So let's take a water molecule. In the water molecules, always we need of 2 hydrogen atom with the 1 oxygen atom. Am I right? So it is 2:1. So the ratio is fixed. This is what definite proportion. But we are not expressed in terms of number of atom. We are expressing the same in the mass. Do you know the weight of hydrogen? What is the weight of
1.
hydrogen atom? Yeah, which is
1.
1 gram, right? And the weight of oxygen atom is
16.
16.
perfect. It is 16 gram. So there are two hydrogen atom, so that this is 2 gram, and the weight of one oxygen atom is 16 gram. Clear? So this is what law of definite proportion. So we are expressing the mass of a substances. The mass of a substance is fixed. If the number of atoms in the compound is fixed, means there is no doubt the mass of an atoms are also fixed. So 2 is to 16. So is it possible to reduce this proportion? We can make it as 1 is to 8,
Oh.
no?
Yes, ma'am.
So
Yes,
this is
ma'am.
a simplest ratio. So we are expressing the proportion or the ratio in terms of mass. So if you see, the compound always contains exactly the same proportion of element by weight. Okay, we are expressing in terms of mass or weight. Clear, everyone?
Yes, ma'am.
Fine. Okay. So next rule is coming, law of multiple proportion. Both are actually same. Only the different thing is, see, I can take carbon plus O2, half O2, it will form carbon monoxide, and carbon plus O2 will form carbon dioxide. Both are same reactants. Reactants, I hope everyone know what is in the LHS side is a reactant, and the new substance is formed is known as a product. If you look at the LHS side, the reactant side, both the reactants are same in the first equation and second equation. First equation is also carbon and oxygen. The second one is also carbon and oxygen. Am I right?
Yes, ma'am.
Very good.
Yes, ma'am.
Only the difference is the second reactant. If you look at the second reactant, I have taken only the half a mole, but here it is, I took 1 mole of oxygen. This is what the difference. So now, what is the weight of O2?
16 grams, ma'am.
Is it
Oh,
16?
32 grams, ma'am.
Perfect. 1 oxygen is 16. I have a 2 oxygen. No. So it is 16 plus 16. So it is a 32. Then what is in half a molecule of O2? 1 molecule of O2 is 32. Like 1 mole of O2 is 32 gram means.
16.
Perfect. It is 16 gram. Yeah, correct. It is 16 gram. Then 1 molecule of O2 is 32 gram. So I will take the proportion for these two. Then 16 gram of 32 gram means it should be 1 is to 2. Correct. Only the difference is the amount of one reactant we are passing into the reaction. That is what different. Am I correct? In this case, for the first reaction, I used up only the 16 gram of oxygen. That is enough for preparation of carbon monoxide. But for the second one, I used 32 gram of water. Sorry, 32 gram of oxygen. Am I correct? To prepare carbon dioxide. So which is 16 into 32, 1 is to 2. Clear, everyone?
Yes, ma'am.
Yeah. Let's move to the next part. Maybe this class we will go ahead with the concepts. So we have some problems related to the mole concept we will do, because once a concept is covered, I'll try to complete in the 1 hour or 1 hour 15 minutes. Then we will go ahead with the problems in the next class. Right? Is it comfortable for everyone?
Yes, ma'am.
Fine. Yeah. Next comes to Avogadro law. Okay, the Gay-Lussac's law, it is actually. The Gay-Lussac's law is also similar. We can compare the law of definite proportion with the Gay-Lussac's law. Okay, law of definite proportion, I'm talking in terms of mass, which is in gram. Am I correct? But Gay-Lussac's law is about gases. It is only for the gases, and we have to express in terms of a volume. That is a simple differences. Okay, the law of definite proportion is in terms of mass, but Gay-Lussac's law in terms of volume. This is a very simple thing. So let's take a hydrogen. We will know H2 plus O2 will give you H2O. Are everyone clear in how to balancing the reaction?
Yes,
Yes,
ma'am.
ma'am.
Everyone know, right? Okay. Will you balance this reaction and tell me?
Yes, ma'am. So
Yeah.
since there is only one oxygen, but here are two oxygens here, we should put a 2 before H2O. And
Superb.
there will be 4 hydrogens now. We should put a 2 before the H in the reactant side.
Perfect. So it is 2H2 plus O2 will give you 2H2O. In case if anyone have doubts in balancing the reaction, also tell me, students. Of course, we will do all those exercise. In case if you have any doubts, okay. So don't hesitate to ask your doubts. Definitely we will sort out all those doubts. Okay. Yes, fine. So now what I can say, two volume of hydrogen, because the coefficient, this is a coefficient, right? So two volume of a hydrogen will react with one volume of an oxygen to produce two volume of hydrogen. So now, what is the ratio of hydrogen and oxygen in the equation?
2:1, ma'am.
Perfect. It is 2:1. The same thing we did in the H2O in law of definite proportion, but it is based on the gram. Am I correct? Here I am talking about the volume. Either you can take 2 liter or 1 liter. Volume in the sense you can take any liter. That's not a problem. Here they have considered 100 ml. So this is 100 ml, 50 ml means. So what is the ratio of 100 and 50? Again, it is 2:1 only.
2:1.
Yes. So clear? The only difference is law of definite proportion. We are talking in terms of mass, but in the Gay-Lussac's law, we are talking in terms of gases and which is volume. Okay. Very important thing, the temperature and pressure to be maintained perfectly. It should be a same temperature and same pressure. Clear? Yes, ma'am. Is there any doubts?
No, ma'am.
Okay, fine. Let's come to Avogadro law. Again, one of the important law. This is also applicable for gases. So let's go directly into the law. So very simple. You have an equal volume of gases. Let's take hydrogen, nitrogen, and then oxygen. Let's consider the volume is 10 liter. So 10 liter of hydrogen, 10 liter of nitrogen, and 10 liter of oxygen. So, and the same temperature and pressure. Let's take it as a standard temperature and pressure, which is 273 Kelvin, 273 Kelvin, and then 1 bar. Okay, either 1 atmospheric pressure or even we can take 1 bar. So this is a standard temperature and pressure. So at same temperature and pressure and equal volume contains same number of molecule. This is what the Avogadro law. Okay, we have to maintain the same temperature, same pressure, and the same volume. If you look out, here you have an 1 trillion molecules means definitely no doubt nitrogen is also 1 trillion molecule and even the oxygen is also 1 trillion molecule. This is what the Avogadro law says. Okay, at same temperature and pressure, all equal volume of the gases contain equal number of molecules. So H2 is 1 trillion, nitrogen is 1 trillion, and oxygen is also 1 trillion. Are you people clear? Is there any doubt in the Avogadro law?
No, ma'am.
No, ma'am.
Yes.
No, ma'am.
Yes, fine. Let's move to Dalton atomic theory. It's a very basic thing. It's not much needed. You go through it. In case if you have a doubts, we will do it in the next class. I want everyone, after the class, I want everyone, you have to read the book. That is very important. Okay. Here I am giving the important concepts which is needed for competitive exams. Yes. Let's come to atomic mass. Very simple. What is an atomic mass? Yes. What is an atomic mass?
Mass of an atom.
That's all fine. It is a mass of an atom, right? Okay. Let's take an hydrogen. What is the mass of an atom?
1, ma'am.
1?
1 gram.
1.008.
Okay. We can say either 1.008, otherwise simply 1 will be enough. Okay. I have a question. So we are finding mass of an atom, right? Atomic mass in the sense it is mass of an atom. Like you are calculating for one atom, right? It's for only one atom. Is it possible to see a single atom? Is this possible?
Without any equipment, it's not possible, ma'am.
Yeah, of course it is not possible, right? Then you are saying that hydrogen has a 1 gram. So is it possible to see a 1 gram object? Of course, yes, right?
Ma'am.
1 gram we can see because we have an ornaments which is 1 gram, 1 gram earrings. We have everything. So the 1 gram can be able to see means definitely the hydrogen atom should be an visible one, right? Then why we are saying we need some equipments to view the hydrogen atom?
But in that 6.023 into 10 power 23 atoms are there, madam.
Yeah, sir. Fine. Thank you, sir. Yes, that is a difference. See, students, hydrogen. Okay, you are talking here for you are multiplying with an Avogadro number. We know that Avogadro number is a big number. So definitely one hydrogen atom is cannot be seen through naked eye. So what is the weight of one hydrogen atom? It is 1. But only the difference is in the unit. Okay, either we can say 1U or 1 AMU. AMU in the sense atomic mass unit. This is a mass of one atom. Wherever you are using U and AMU, either it is for one atom or one molecule. If you are using a gram mole inverse, this is for Avogadro numbers. Are you people clear? Okay. Avogadro number is hextrillion of an atom. Okay.
Madam,
So
just
imagine-
one clarification for me. Suppose if I want to measure weight of one hydrogen atom, that is equal to 1 divided by 6.023 into 10 power 23 gram?
Yes, sir. Yes, sir. That's
Okay,
right.
okay.
Yes, sir. Okay. So, listen carefully. See, let's take an one apple weight. Okay. One apple weight is, let's take maybe a 0.5 kg. Okay. So, dozen of apple, let's take means it will give you one value, right? That is for the same thing. Avogadro number of hydrogen atom is 1 gram mole inverse. Okay. One atom is 1 U. U in the sense which is again a small unit, very less unit. So 1U or AMU. Okay, that is for one atom. If you take Avogadro number, the hextrillion of atom is 1 gram mole inverse. You can consider it like this, like a person whoever using the glass, like specs I'm talking about. In specs, is it possible to see one sugar crystal? Is it possible to see the one sugar crystal without specs?
No, ma'am.
No, it's not possible, right? But you are placing an 1 kg of a sugar crystal. Without specs also, the person can see the 1 kg of a sugar. Am I correct?
Yes, ma'am.
Because
ma'am.
1 kg of a sugar is very big. Am I correct? That's the reason. So Avogadro number of hydrogen atom we can see because it's a huge number of an atoms, which is 1 gram. But if you take a one hydrogen atom, which is very, very small, and the unit is not gram, which is U or AMU. Are you people clear? Is there any doubts?
No, ma'am.
Ma'am.
So very important relationship is AMU. 1 AMU is equal to how much gram? See, 10 to the power of minus 24. 10 to the power of minus 24 means is it a big value or a small one?
Small value.
Yeah, it's a very small value. So imagine 1 gram we can see, but 10 to the power of minus 24 gram, definitely we need some equipments to view the object. This is what given. Okay, yes. So now in this example, they are finding the mass of hydrogen atom in AMU, one hydrogen atom. Okay, so 1.6736 is actually the mass of hydrogen atom in gram divided by the standard weight. 1 AMU is 1.66 into 10 to the power of minus 24. So finally, I got the value of 1.0080, which is the weight of one hydrogen atom. One hydrogen atom. So wherever one hydrogen atom or a one molecule you are talking about, you have to either use U or AMU. The full form of AMU is atomic mass unit and U means unified mass. Clear everyone?
Yes, ma'am.
Fine. Let's come to average atomic mass. Is there any idea about average atomic mass? Yes. What is mean by average atomic mass? Usually,
The isotopes, ma'am.
yeah, it is calculated for the isotope. Average atomic mass is only for the isotope. Perfect. Okay. Like where we will do average usually?
Ma'am, to find the percentage, ma'am.
Yeah, to find out the percentage. Okay, let's take, you have 3 apples given. One apple is 3.5 kg, another one is 0.6 kg. 0.6 kg, 0.5 kg, 0.5 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 kg. 0 minute. We'll scroll down. Where it is. Okay, another one is 0.6 kg and another one is 0.3 kg. So you need to find the average apple weight. So how you will do usually?
Ma'am, we have to add all the three
And
things.
divide by
Divide
3.
by three, ma'am.
Perfect. Yes. 0.5, 0.6, 0.3. Sum of all those things divided by 3. This is what we will do usually for average. But what's the problem here means isotope, hope everyone know. Isotope is nothing but same atomic number, different mass number. For example, if you have taken the carbon are in the isotope. Atomic number of carbon is 6 and 6, but the mass number is vary. Okay, same atomic number, different mass number means this is what called as isotope. Okay, okay. Now here I need to calculate the average mass. So mass number is nothing but average. Like mass number is nothing but mass of the atom. Am I correct? Mass number is simply the mass. Am I
Yes.
right or wrong? Then,
Yes.
so C12 is there, C13 is there, C14 is there. Then I can do simply 12 plus 13 plus 14 divided by 3. No, this is the right way to find out the average. Then why they have given percentage and there are some different formulas? Is there any idea? Why we want to move with a different formula? Because average in the sense sum of all the masses divided by the total numbers. So it should be a 12 plus 13 plus 14 divided by 3. Then why we want to move with a different formula means because all are not in the equal proportion. Here this is a one apple, this is a one apple and this is one apple. The numbers are equal, right? It is equal in numbers. But if you took carbon 12, the carbon 12 is maximum in the atmosphere. And if you take a carbon 13, this is a different percentage. And the carbon 14 in the different percentage. If all the quantities are exactly similar, then I can put 12 plus 13 plus 14 divided by 3. So here everything in the different ratios or the different percentage. That's a reason we have one formula. I want you to write down the formula in your book or in your note. So the like average atomic masses equal to percentage into percentage of one isotope. Okay, I'm not writing in detail. So percentage of one isotope plus mass of the one isotope plus the percentage of the second isotope and the mass of the second isotope. So continuously it goes on. In case if you have a third isotope, it will continuously goes on divided by 100. Are you people clear why we are taking a percentage? Because the ratios are not similar, right? All are the 50%, 50%, 50% means that is okay. All are in the equal ratios means we can go ahead with 12 plus 13 plus 14 divided by 3. But here the isotopes are in the different percentage. That's the reason the percentage of one isotope into mass of 1 plus the percentage of the second one into mass of 2 divided by 100. Is there any doubt in this question?
This is what is said as weighted average, madam.
Yes, sir.
Okay, okay. Thank you. Thank you.
Yes. Students, are you people clear?
Yes, ma'am.
Okay. So there is one book back exercise in this percentage of mass. So I think we don't want to spend too much time in the calculation. So it will take much time. So I want someone to say how to do the 1.32 sum. Here they are asking to find out the average isotope. Average atomic mass, either you can say molar mass also. Molar mass is also one correct word. How we need to do? The percentage is given and isotopic mass is given. What I need to do is 0.33. This is a percentage of the first isotope into the molar mass. Don't take all the values. After decimal, just take the two values. That is enough. So 0.33 into 35.96 plus, then I have to go ahead with the second isotope. Then this is 0.06 into 37.96. 37.96 plus, okay, you have to multiply the percentage and mass, but the next thing you have to add it. Okay, the third isotope, 99.6 into 39.96. So you have to add all those value, do multiplication first and then add divided by 100. Okay, this is your answer. Are you
Madam,
people clear?
madam, can I interrupt
Yes, sir.
for a minute? இப்போ இந்த
Yeah, sir.
இந்த கொஸ்டின்ல ஆன்சர் எவ்வளவு வரும்னு நினைக்கிறீங்க? கெஸ் பண்ண முடியுமா குழந்தைகளா?
Yes, sir.
Can you guess how much will be the answer approximately? Can anybody guess approximately? Can you guess what will be the answer? Not I mean, I don't want your calculation. Calculate பண்ணி சொல்ல வேணாம். அப்படியே கண்ணில் பார்த்து அப்சர்வ் பண்ணியே சொல்லணும். எப்படி ஒரு 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 பர்சனை முகத்தை பார்த்து போலீஸ் வந்து திருடன்னு சொல்கிறான் அது மாதிரி. Here you have to find what will be the value. Will it be closer to 35 or closer to 37 or closer to 39?
I think it will be closer to 39.
39, is it be lesser than 39.96 or will it be more than 39.96?
It will be lesser than the 30.
Yeah, little lesser than 39.96. இப்படி தான் நீங்கள் எக்ஸாமில் பண்ணணும் இல்லைங்களா மேடம்?
Yes, sir. Correct, sir.
Yeah.
Perfect.
Okay, thank you. Thank you, madam.
Thank you, sir.
Sorry for the interruption. I'm just
No, sir,
giving you
no,
some.
sir.
No, ஸ்டூடெண்ட்ஸ்க்கு இல்லைன்னா இந்த கேல்குலேட் பார்த்தோன்னா அவங்க தூங்க போயிடுவாங்க. இது எப்போ நம்ம பண்ணி எப்போ முடிக்கிறதுன்னு. யூ நீட் நாட் கேல்குலேட் இன் த எக்ஸாம். ஜஸ்ட் பை அப்சர்விங் யூ கேன் ஆன்சர் த கொஸ்டின்ஸ். தேங்க் யூ.
Yeah. Yes, sir. Thank you, sir. Yes. See, எப்பயுமே வந்து like average atomic mass, it should be in the range of lower atomic mass and higher atomic mass. For example, here the lower molar mass is 35.96. No. And the higher atomic mass is 39.9. So definitely your final answer should be in this range. And again, you can see directly as the percentage of the third isotope is higher, so you will get mostly related to 39 value. So lesser than 39.96. So as sir said, and the student, very good answer. Is it clear, students? Is there any doubt in this part?
No, ma'am.
Clear? Everyone clear? Okay. So I want you people, you can take it one. We have one more sum related to this. I think you can take this as an homework. Yeah, this one 1.9. Okay, in the NCRT, you can check the book back exercise of 1.9. Okay, I want you to calculate this sum, not now, in the next classes. Okay, I'll ask you what's the answer for this one. Again, you will be getting the lower two in between the value of 36 to 34. Yeah, let's come back to the concept again. Because still we didn't go for the big concept. The very important concept is limiting reagent and then percentage. That only we have many problems. That's the reason today I didn't go for problems. Okay, mole concept is very important and empirical formula is very important. So maybe that we will discuss in our next class. Yeah, let's come to the molecular mass. Molecular mass means again very simple, mass of one molecule. Wherever you have a U or AMU, understand it's a only one molecule. Okay, let's take an H2O. Will anyone tell me what is the weight of H2O molecule?
18, ma'am.
18 gram.
You have to, yeah, 18 gram or 18 U.
2, ma'am.
It is U, 18 U. Wherever one molecule comes means you have to say it is an 18 U. So I'm talking about Avogadro number of 18 H2O. Then only it is an 18 gram. Am I correct? Right?
Yes, ma'am.
Yes, fine. Yes. Then let's come to formula mass. Formula mass is also almost similar. Only the difference is this is calculated for ionic compounds. That's all. Very simple. Formula mass is for ionic compounds. This is about the ionic compounds. So we are seeing the gist of this lesson. Okay? Yeah. Let's come to the mole concept and molar mass. So molar mass means always it should be in the gram mole inverse. The unit of molar mass is gram mole inverse. Are you people clear? Is there any doubts?
No, ma'am.
So far? Is there any doubt, students?
No, ma'am.
Okay. So now I'll move with the mole concept. I'll do it in the whiteboard so that it's a bit comfortable for me. Okay. So in the case of mole concept, yeah. I think this is not too nice. Fine. Okay. So I want everyone to write all this concept. Mole concept. Okay. If you understood this concept clearly, then it is very easy to solve many problems. This is most important part. Okay, the mole concept, in this we are going 3 steps. Okay, the first step is I'm going to relate the mole. What is a mole first of all? What is mean by mole?
1 mole is the amount of substance which contains 6.023 into 10 to the power of 23.
Super, perfect answer. So simply, what's the definition can be given for a mole is a unit of chemical substances. That's all, right? It's a unit of chemical substances. So the chemist person, the scientist and all, they won't say take this much gram of hydrogen, mix it with this much gram of water, mix it with this much gram of oxygen, you will get this much gram of water. They won't say like that. So take 1 mole of hydrogen or 2 mole of hydrogen, react with 1 mole of water, react with 1 mole of oxygen, you will get 2 moles of water. This is the way they used to say. So mole is nothing but unit of chemical substances. Okay, this is a unit of chemical substances. There are 3 ways to find out the mole concept. First, we are going to relate with the grams, weight. 1 mole of any substances, 1 mole of any chemical is equal to the molar mass of the chemical. Okay, molar mass of that chemical. Let's go with 1 mole of CO2. These are all some examples. Let's take 1 mole of CO2. What is the molar mass of CO2? How I need to calculate? The weight of carbon plus the weight of 2 oxygen, right?
Yes.
Carbon is 12.
44.
Superb. Carbon is 12 and there are 2 oxygens, so which is 2 into 16. So it is 44 gram mole inverse. So wherever you have a molar mass, you have to say in terms of gram mole inverse. The unit is gram mole inverse. So 1 mole of all the substance is equal to the molar mass. Let's go with the one more problem. What is a 1 mole of hydrogen atom? Yes? What is a 1 mole of hydrogen atom? Very simple question.
1 gram mole.
Yeah, that's all. This is 1 gram mole inverse. That's all. Let's go with 1 mole of H2. What is the 1 mole of H2?
2, ma'am.
2 gram
Yeah.
mole inverse.
Yes, it is 2 gram mole inverse. Are everyone clear how to find out? We'll go with the one more problem. 1 mole of NH3. Will you tell me what is 1 mole of NH3? Nitrogen has atomic mass of 14.
14.
14
Gram.
17 mole inverse.
17 gram mole inverse. Yes, fine. Okay. So
Madam,
this
I
is
just
about-
have one question. If you
Yes, sir.
say 1 mole of H2 equal 2 gram mole inverse, it means that 2 divided by 6.023 into 10 power 23 gram. Am I correct?
Yes, sir. Yes, sir.
அது புரிஞ்சிருக்கா குழந்தைகளுக்கு ஏன் மோல் இன்வர்ஸ்னு என்னன்னு புரிஞ்சிருக்கா?
See, mole inverse in the sense like 1 mole. For per mole only we are finding, right? So per mole only we are finding. That's the reason we are putting mole inverse. That's all.
அது அந்த அந்த குழந்தைகள் கரெக்டா புரிஞ்சுக்கணும். அது that is very important.
Yes, sir. Right.
Okay.
So mole inverse in the sense for per mole. We are do it for per mole. Okay. If you put for 2 moles means like, let's do it one more question. Sir is pointing out this. So 2 mole of H2. So if we are taking 2 mole of H2 means what's your answer? Any of you? Any one of you? What is 2 mole of H2?
Mole inverse.
Yeah,
4
yeah.
moles.
It is only 4 gram. Don't use the mole inverse in that case. Okay. Mole inverse means for per mole. Here I am taking 1 mole so that I am putting for per mole, right? Here it is a 2 mole means the mole inverse won't come. Okay. Are you people clear? Only where and all you are calculating for 1 mole, then only you have to use mole inverse. Here it is in 2 moles. 2 moles means it's not right to put mole inverse. Are you people clear?
Yes, ma'am.
Yeah, fine, superb. I think for today's class, this is enough. Is it an enough, sir? Shall we continue the remaining in the next class?
Yeah. We can continue next class. Couple of things we will now request the students to
Okay, sir.
give their little feedback to madam straight away.
Yes, sir.
You can tell whether you have understood whether the speed with which madam is going is okay. Can you give any one of you? Maybe I'll go with say Raghavi. நீங்கள் சொல்லலாம் எப்படி இருக்குன்னு ஏன்னா we will not
Be frank, okay? In case even if I want to slow down also, you can tell me. We will do it slowly.
என்னோட ஒரு சஜஷன் மேடம் ஸ்ருதி மேடம் கொஞ்சம் ஸ்லோவாக போகலாம்.
Yes, sir. கொஞ்சம்
ஸ்லோவாக
போய்க்கலாம்.
போகலாம். இன்னும் கூட அந்த கொஸ்டின் கேட்குறீங்க இல்லையா, யூ கேன் கிவ் லிட்டில் மோர் டைம் ஃபார் தெம் டு ஆன்சர்.
Okay, sir.
ஆமாம், அவங்க கொஞ்சம் they may take some time to answer, little more time. அது ஒன்று எனக்கு தெரிஞ்ச ஒன்று. வேற என்ன சொல்கிறீங்க? விஸ்வேஸ்வர், விஸ்வேஸ்வர், யூ கேன் கமெண்ட்.
Ma'am?
Yeah.
Ma'am, your teaching is very good, ma'am. But now we are starting to study the chemistry in depth, ma'am. So we can't understand the concept easier, ma'am. So we have some time to understand, ma'am. So that you can go slowly, ma'am.
Yeah, fine. I'll do it slowly.
Ideal situation for us, madam, after that subject was taken in the school, if we come to the class, then that would be better. So far I think they have covered half the syllabus or half the chapter or something, or offer, because almost only 2 weeks have gone. This is one thing. Maybe no, but over a period of time, by the time next week, I think they would have covered many things. So it will take care. That is one of the reasons why we delayed. What we did was, for 2025 batch, initial 2 weeks we did 10th portion. And then only this week we are starting 11th portion. Of course, you joined this week, so it is straight away 11th portion. So like that you can look at that. So that is one. Secondly, Akshaya, how did you understand?
The class was very good, sir. I was able to understand everything really well.
Okay, right. So now, as madam said, as we are also telling, most of you are state board students, you buy the NCERT books and keep it with you, at least for the exam, this competitive exam purpose. That already we have said, you can, and I have given the address also for whom you can buy. Just for 1,000 rupees, you get both 11th and 12th physics, chemistry, biology books. 10 books he gives for 1,000 rupees. I have negotiated, already Santosh has got. Couple of others, you can get it from them straight away. If you send 1,000 rupees to that fellow, he will send by parcel to you. But before that, you have talked to him and find out, because so far I have bought 6 or 7 copies, 7 bundles. So he has paid in time, sent in time. But then these traders, we have to be very careful. He sits at Tiruchi, not in Coimbatore. That is one thing. And you keep it there so that when our class comes in CBSE book, it may be easy to understand. That is the one thing which I wanted to tell to the students. Otherwise, Santosh, எப்படி இருக்கு?
Sir, class is very superb, sir.
அதான் இவங்க எடுக்கிறது நம்ம நிவேதிதா மேடம் மாதிரி எடுக்கிறாங்கல்ல?
Yes, ma'am.
ஆமாம், அதே மாதிரி எடுக்கிறாங்க. எனக்கு ரொம்ப ஆச்சரியமாக வேணும். We have one teacher, madam, நிவேதிதான்னு சொல்லி. For 12th chemistry she takes, but she is getting married next week. In the week. அதனால she will be coming. Almost ditto. அப்படி நல்லா அழகாக எடுக்கிறீங்க. Very nice. I liked it. I liked அது இளவரசி, the first class இளவரசிக்கு நீங்கள் என்ன நினைக்கிறீங்க?
Sir, the class is super and I can able to understand.
ஒன்றும் பிரச்சனை இல்லையா? உங்களுக்கு அண்டர்ஸ்டாண்ட் பண்ணுறது பிரச்சனை இல்லையா? யார் 2 கிளாஸ் மிஸ் பண்ணோன்னு வருத்தப்படுறீங்களா?
நான் YouTube linkல பார்த்தேன்.
ஓ, பார்த்துருக்கீங்களா? ஓகே.
If I miss that, I will.
ஆனால் யூஸ்வலாக லிங்க்ல பார்க்குறத விட நேராக அட்டன் பண்ணும்போது இன்னும் நல்லா இருக்கும். கீர்த்தி மாலினி, கேன் ஐ லிசன் டு யூ? கீர்த்தி மாலினி, உங்கள் கமெண்ட் சொல்லுங்க கண்ணா.
சார் நாங்க ஸ்கூல்ல எடுக்கிற டவுட்ஸ் எல்லாம் இவங்க கிட்ட கேட்டுக்கலாமா சார்?
எல்லாம் கேட்டுக்கலாம் நீங்கள். அதுக்காக என்னை ஒரு பையன் கேட்டான், சார் உங்கள் வாழ்க்கையில் உங்களுக்கு என்ன சார் வருத்தம் அப்படின்னு கேட்டான். அந்த மாதிரி டவுட்லாம் கேட்டுறாதீங்க. இது மாதிரி தான் நான் சொல்லி, உங்கள் வாழ்க்கையில் உங்களுக்கு என்ன வருத்தம்னு ஒரு கேள்வி கேட்டான். அந்த மாதிரி ஜோக்கெல்லாம் நீங்கள் பண்ணக்கூடாது, சரியா? கேட்கலாம் தாராளமாக. சப்ஜெக்ட் கொஸ்டின்ஸ் நாட் ஓன்லி இன் த கிளாஸ், யூ கேன் புட் இட் இன் த குரூப் இட் செல்ஃப். ஐ ஹவ் ஆடட் மேடம் இன் அவர் 2025 குரூப்பில் மேடத்தோட நம்பர் ஆட் பண்ணிட்டேன். அங்கேயே கூட அவங்க முடிஞ்ச ஆன்சர் பண்ணுவாங்க, இல்லைன்னா கிளாஸில் வந்து ஆன்சர் பண்ணுவாங்க.
ஓகே
சார். ஸோ நம்ம மேடம் ஸ்ருதி மேடம் நாங்கள் என்ன பண்ணுறோன்னா, we are 24/7 லேர்னிங்காக மாற்றிட்டோம். That is, in the group, students can put questions, they can answer. I can put questions, you can put questions, anybody can put questions, anybody can answer. It may not be correct or may not be, may be wrong. And நீங்கள் as a teacher, நீங்கள் எடுத்தோடனே நீங்கள் ரிப்ளை பண்ண வேண்டாம். You wait for some many students to reply, and then you come up with your answer. By the time it comes to your time, they would have got the right answer. And learning through a student, through another student, is the best way to learn, which we all know. நம்மெல்லாம் அப்படி தானே படித்தோம். அதனால பட் வெரி இன்ட்ரெஸ்டிங் மேடம். இன்ஃபேக்ட் ஐ ரியலி லவ்ட் யுவர் கிளாஸ். This is the way we should go. Anyway, thanks a lot for coming over and supporting our mission and our students. Students, I again repeat, வீடியோ பார்த்தா மட்டும் பத்தாது, நேராக வந்துட்டிங்கன்னா இன்னும் பெட்டர். பிகாஸ் வீடியோ பார்க்குறதுல பிகாஸ் அந்த ஸ்க்ரீன் சிறுசாக தெரியும், அது அப்புறம் கண்ணுக்கு தெரியாது, அதெல்லாம் நிறைய ப்ராப்ளம்ஸ் இருக்குது. ஸோ யூ கம் டு த கிளாஸ், பிகாஸ் எப்படியும் அங்கே ஒரு ½ hour 1 hour செலவு பண்ணுறீங்க வீடியோவுக்கு, அது இங்கேயே ஆஸ் வெல் யூ கேன் கம் டு த கிளாஸ் அண்ட் டூ இட், இல்லைங்களா? இந்த வீடியோ யாருக்குன்னா சில குழந்தைங்க வர முடியல, ஏதோ அதுக்காக ஒரு வீடியோ வச்சுக்கோங்க. வீடியோ பார்த்து நம்ம படிக்கிறதுங்கிறது, பிகாஸ் நம்ம வீடியோ அவ்வளோ ஒரு ப்ரொஃபஷனலாக பைஜு மாதிரியெல்லாம் நம்ம பண்ணவும் முடியாது. அது வேறு, அது வந்து டிஃப்ரெண்ட் லெவலில் பண்ணுறாங்க. நம்மளது வந்து கிளாஸ் அப்படியே ரெக்கார்ட் பண்ணி we are keeping it in the class. Thanks madam. I mean you can I think it's very interesting. I think this is a way to go. Only thing is எனக்கு